Okay, so we're given a bunch of information in this problem that isn't all translated to the diagram. So that's the first thing we want to do. So point A is 1, 1. Point B is 6, 1. Line segment RS. R is point, come on, there we go, 0.5 and 5. And then S is at 7 and 5. And we need the distance from B to P. So that would actually be a straight line. Well, it would be a line like this. So it's going to be a triangle. And then it's going to help us out to imagine a line straight from P to the line AB, and we'll just call this point C. We can do some figuring out here. So AB, line AB, if it goes from 1, 1 to 6, 1, we know that AB has a length of 5. We also find out that the length from A to P is 5. So we got that there. And so we know AB is 5. We know that RS, since it goes from 0.5 to 7, it has a distance of 6.5, which might be handy later. So the next thing we can figure out now is that the distance between the two lines, since this one is parallel, the top line, RS, is line segment, is parallel to the x-axis, and AB is also parallel to the x-axis. We can tell because the y-coordinate stays the same across each of them, 5 and 5 and 1 and 1. The distance between those is 4. So we now know the height of this, and now we see here that ACP is a 3, 4, 5 triangle. Remember, that's one of those Pythagorean triplets, where if you have two of those numbers or multiples of those numbers in a triangle, you can figure out the third one. So AC must equal 3, and we already established that AB, the whole line segment down here, is 5, so CB must be 2. Now we have two of the three sides of a right triangle, and we can use the Pythagorean theorem to find the rest of this mysterious line BP. So 4 squared plus 2 squared is going to equal BP squared. So 16 plus 4 equals BP squared. BP squared equals 20. Therefore, BP, because you can factor out a 4, 20 is 4 times 5, factor out a 4, and so the square root of 4 is 2. BP equals 2 times the square root of 5. Answer choice C.